Hi. We're going to cover three sets of identities today. As in the title, we're going to do the sum and difference identities, the double angle identities, and the half angle identities. You should find in Canvas posted the identity page for chapter five. It has the sum and difference identities down here on the bottom for sine and cosine and tangent. We're not going to use tangent, but it's there. And then on the back is the double angle for sine and cosine, pi reducing, which we're not going to use, and then the half angle for sine and cosine and tangent as well. Again, we won't be doing tangent. We'll just be focusing on sine and cosine, and then we won't be doing those power reducing. Let's start with sum and difference. So these are the sum and difference identities for sine and cosine. The sine says if you have two angles added or subtracted, then the identity looks like this. Notice AB, 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 and in the middle, the plus or minus is the same plus or minus. With the sum and difference for cosine, it's cosine, cosine, sine, sine, and this is flipped. So when you're adding two angles together, it's subtraction in between the two, and I'll show you an example of what that looks like. So if I have the sine of 75 degrees, I can find its exact value by rewriting it as the sine of 30 plus 45. Now, you want to choose two angles that are on your unit circle, two angles that are 30, 45, 60, 90, and then any of those reference angles would be in any other quadrant. So generally, you're going to be using quadrant 1 and quadrant 2, 30, 45, 60, and then 120, 135, and 150. So 75 can be made up of 30 plus 45. So 30 is my A, 45 is my B, and then I'm going to plug those into this little formula right here everywhere I see an A and a B. So it's going to look like the sine of 30 cosine 45, and then it's the same plus minus plus minus. So if there's plus right here, I'm putting plus right there, and then cosine 30 cosine, hang on, let me move this over. It's running into that. Sine 30 cosine 45 plus cosine 30 sine 45. And then you either go to your special right triangles or your unit circle and figure out what the exact value for the sine of 30 is. Cosine 45, cosine 30, sine 45. So if you're using your special right triangles, the 45, 45 is a 1 square root of 2, right? The 60, 30, 90 is a 1, 2 square root of 3. So the sine of 30 degrees is 1/2. The cosine of 45 is 1 over the square root of 2. You could also use square root of 2 over 2, which is what I'm going to do here. Remember that 1 over the square root of 2 is the same as the square root of 2 over 2. And then cosine 30 is square root of 3 over 2. 45 is square root of 2 over 2 again. And so then when you multiply two fractions together, you just multiply straight across the top, straight across the bottom. On both of those, you get square root of 2 over 4. And then here, the square root of 3 and the square root of 2 multiplies to make the square root of 6 over 4. And then combining your two fractions, you get square root of 2 plus square root of 6 over 4. Now, you cannot simplify that. Do not try to simplify it. This is simplest form right here, and this is the exact value of the sine of 45 degrees. Leave it like that. Do not try to simplify it. Okay, so we're going to do another one. Next one would obviously be a cosine identity. So I'm going to erase this one. And on this one, we're looking for the cosine of 7 pi over 12. Now, 7 pi over 12 is an angle in radians and not degrees. So what does 7 pi over 12 equal in degrees? If you substitute the pi and 180 in for pi, you get 105 degrees. Sorry. So I'm looking for the cosine of 105 degrees. And then I can break the 105 into 45 plus 60. You could also do 135 minus 30. That would get you 105. You could do 150 minus 45. So there's lots of ways to come up with this 105 if you're adding and subtracting two angles from each other. So you basically just pick one combination that makes 105, and it doesn't matter which combination you use. And then we use this identity. So it looks like the cosine of 45, the cosine of 60, and then it's opposite. So if it's plus here, then it's minus there, and so on. So minus here, plus here, minus. So if it's plus in between the two here, we're going to put subtraction in between the two parts here. And so then it would be sine 45, sine 60. Now we already talked about these in the last problem. So 45 is the square root of 2 over 2. Cosine of 60 is 1/2. Sine of 45 is square root of 2 over 2. And then sine of 60 is square root of 3 over 2. And so then I get square root of 2 over 4 minus square root of 6 over 4, and leaving my answer like that. Make sure that you have your answer in exact form like this, not in decimal form. If you type the cosine of 105 into a calculator, the calculator will give you a decimal approximation for the cosine of 105. I want you to use the identities to come up with the exact value for the cosine or sine or whatever they're giving you. Okay? All right, so the next set of identities we're going to look at is the double angle identities. Okay, there are actually three options for the cosine double angle identity. On your identities paper here, the cosine of 2u has three options there. Any one of those three options would work. This one is the first one and just the one I'm going to use today. So feel free to use one of the other two if you like them better. But this is the cosine and the sine double angle identities. Okay, so they're going to give you a ratio for one of the six trig functions, probably going to be secant, cosecant, tangent, cotangent. They're giving us a ratio and they're giving us a quadrant. So it's telling us that the angle is between pi over 2 and pi. So that means that our angle is in quadrant 2, right? Between 90 and 180. And then this, our secant, is the reciprocal of cosine, right? So cosine is adjacent over hypotenuse. That means secant is hypotenuse over adjacent. So what we have, I'm going to draw a little picture over here, is an angle in second quadrant, right? It doesn't matter where I draw it. And then if I draw my little reference triangle, my little reference angle goes right here, then my 12 goes on this adjacent side and my 13 goes on the hypotenuse. And I know that one of them is negative according to the fact that this fraction is negative and I can't be the hypotenuse. And since I'm going to the left on the x-axis, it's the 12. And then I would just do a squared plus b squared equals c squared. And find that the side opposite is 5. And then it's in the upward direction, so that's a positive 5, not negative. And so then I would just take for the sine of 2 theta and use my little formula right there. It looks like 2 times the sine of the angle times the cosine of the angle. So it's 2, and then the sine of the angle would be opposite over hypotenuse, so 5 thirteenths, and then the cosine of the angle is negative 12 thirteenths. And so multiplying straight across, this is like a 12 over 1, right? I'm sorry, this is a 2 over 1. If I multiply straight across the top and straight across the bottom, I get 129. Sorry, 120 over 169. Sorry, having trouble speaking today. So 2 times 5 times 12 is 120. 13 times 13 is 169. So we're going to do the same thing with the cosine double angle. I'm going to use that one there that says the cosine squared minus the sine squared. And since I know the cosine of the angle is negative 12 thirteenths, and I'm going to square that. And then the sine of the angle is the 5 thirteenths, and I'm going to square that. I get 144 over 169 minus 25 over 169, and that leaves me with 119. 169. So it's just using the formula, plugging in the value for that given, oops, I forgot my little theta right there, sorry. There. It's just plugging in the value from the triangle. So cosine was 12 thirteenths, sine was 5 thirteenths. When I square that and I square the negative 12, I get 149. When I square the 13, I get 144 over 169, sorry. So the half angle identities look really, really complicated, and they're not as complicated as they look. So the half angle for sine looks like this. And the half angle for cosine so this one is 1 minus the cosine of the given angle. This one is 1 plus the cosine of the given angle. And the problem you're going to have is very similar to what we just did here. You're going to be given some information. For example, the cosecant of the angle is negative 5/3, and the angle is between pi and 3 pi over 2. So very similar to the last problem, and you're being asked to find either the sine of the half angle or the cosine of the half angle. So we'll find both for this example. So what is the information at the top telling us? This is telling us we're in quadrant 3 between pi, which is 180, and 3 pi over 2, which is 270. And this one is giving us the ratio, right? So cosecant is the reciprocal of sine. So this is the opposite and the hypotenuse, like so. And so then I'm going to do the same thing I did on the last one. I'm going to draw a picture of what we're talking about. Here's our angle. It's in the third quadrant. Here's our little reference triangle. And reference angle goes right there. And so the hypotenuse is a 5, and the opposite side is a 3. And one of them is negative because the fraction is negative. And in this case, it's the 3, right? Because the 5 has to be positive. Always the hypotenuse is positive. So then we do a squared plus negative 3 squared equaling 5 squared. And we get a is equal to 4. And that means that it's going to be a negative 4 on the adjacent side of the triangle, again, because we're going to the left and down, right? To the left gives us a negative value, to down gives us a negative value into the third quadrant. Okay, so using our formula up there, the cosine of the angle is negative 3/5. So this looks like plus or minus 1 minus 3, negative 3/5. Oh, sorry, not negative 3/5, negative 4/5. The cosine is negative 4/5 adjacent over hypotenuse. So this math right here, 1 minus a negative 4/5 is the same as 1 plus 4/5. And 1 plus 4/5 is the same as 5/5 plus 4/5. So 9/5. So we end up with 9. That's not, doesn't look like a 9, sorry. 9/5 divided by 2. And so then again, kind of some scratch work on the side. 9/5 divided by 2 is the same as 9/5 divided by 2, or 9/5 times 1/2. Again, when you're dividing by fractions, you change that to multiplication by multiplying by the reciprocal. So flip the guy and multiply. This 2 gets flipped over to be a 1/2. And so we end up with 9/10. I can take the square root of 9. The square root of 9 is 3. And then rationalizing the denominator, the answer would look like that. So again, let me show you this in one kind of slow-mo. So the square root of 9/10 is the same as the square root of 9 over the square root of 10. Well, I can take the square root of 9, and I can't leave the square root of 10. Mathematical etiquette says don't leave a radical in the denominator of a fraction. So I end up with 3 square root of 10, and on the bottom that's the square root of 10, and the square root of 10 leaves me with 10. Okay. So we're going to do the same thing. It's going to be very similar, right? The formulas look very similar. The difference is the minus and the plus. So addition, subtraction. So plus or minus the square root. In this case, we're adding the negative 4/5 to the 1. And then 1 minus 4/5, or adding a negative 4/5. 5/5 minus 4/5 leaves me with 1/5. Dividing it by 2 is the same as dividing or multiplying by 1/2, right? So we end up with plus or minus the square root of 1/10. And very similar to the last one, when we rationalize that denominator, we get the square root of 10 over 10, like so. So when I have plus or minus the square root of 1/10, that's the square root of 1 over the square root of 10. And we rationalize the denominator. So we have a square root of 10 and a 10, like so. Just a little. Okay. That's everything for sum and difference, double angle, and half angle identity.